From most of human history, when we've wanted to build something big, something complicated, think a cathedral or a computer, we've always started with a blueprint, right? The assumption has always been that to build something great, you have to design it perfectly from the top down. But what if that's completely wrong? What if the most complex, most incredible things in our universe, from life itself to what's coming with AI, what if they can't be built at all? What if they have to be grown?
So this really sets up a fundamental clash of two different ways of thinking. On one side, you've got the architect. The architect is all about top-down control, detailed plans, and getting a predictable outcome. You build a machine, you know what it's going to do. But on the other side, you've got the gardener. The gardener works from the bottom up. They plant simple seeds, they get the environment just right, and they nurture what starts to grow on its own. They cultivate living systems. And for centuries, the architect's way of thinking has been king. But that's all starting to change, and fast.
So let's really dig into the architect's dream for a second. It's a really attractive idea, honestly, because it promises something we all want: absolute control. It's this fantasy of a perfect clockwork universe, a reality where every single piece, no matter how complex it seems, can be completely understood and predicted if we just have enough data.
Yeah, this has been the core ambition of science for ages. It's this idea of Laplace's demon, a kind of thought experiment about a super intellect that could know the exact position and momentum of every atom in the universe. If it knew that, it could calculate the entire future, right? From the next star to explode to what you're going to have for breakfast tomorrow. The goal was to basically find the ultimate cheat code for reality.
But that dream, that beautiful dream of perfect prediction, runs headfirst into a brutal and kind of beautiful truth about how the universe actually works. There's a glitch in the system, a glitch that proves some things, even incredibly simple things, are just fundamentally unpredictable.
And to understand this glitch, we're going to use a surprisingly simple tool. It's called a cellular automaton. Seriously, just picture a grid of squares, like you see here. Each square can be either on or off, black or white. And the state of each new square is decided by a super simple rule based on the 3 squares right above it. That's it. It's a totally deterministic system. There's no randomness, no hidden tricks.
And check this out. Here is one of the simplest rules you can possibly imagine. It's famously called Rule 30, and it was discovered by Stephen Wolfram. The entire set of instructions is incredibly basic. You give it any pattern of 3 cells, and the rule tells you exactly, with no ambiguity, what color the cell below has to be. Simple inputs, simple rules.
Okay, so here's the million-dollar question. If we start with the simplest possible input, I'm talking just a single black cell at the top, and we apply this simple deterministic rule over and over and over, we should get a simple, predictable pattern, shouldn't we? I mean, it seems obvious.
Nope, completely wrong. What you get, what emerges, is this breathtaking mix of structure and total chaos. This phenomenon has a name. It's called computational irreducibility. So what on earth does that mean? It means there is no formula, no fancy mathematical shortcut anywhere in the universe that can tell you what this pattern is going to look like 10,000 steps from now. The only way to find out is to run the simulation step by painful step. The system is its own fastest predictor. And this isn't just some weird math thing. This is a deep truth about why things like neural networks can do what they do. Powerful, but also unpredictable. The architect's dream is completely shattered.
Okay, so if we can't blueprint complexity from the top down, how in the world does the universe create it? Well, the answer comes from the gardener. It's a whole new philosophy called design by emergence. The idea is, you don't build the final thing, you create the conditions for it to grow itself. So, what's the recipe for this kind of emergent magic? Turns out you only need 2 things. First, simple building blocks. Think of them like atoms or computer bits or even just Lego bricks. And second, you need a set of simple rules that tell those blocks how to interact with each other. Do they stick together? Do they push each other away? That's it. Simple blocks and simple rules. That's the seed from which all the complexity in the universe grows. But here's the thing. Not all rules create interesting stuff. Stephen Wolfram actually sorted the results into 4 basic classes. Class 1 systems, they just fizzle out into a boring flat state, kind of like a sheet of steel. Class 2 systems get stuck in these simple repeating patterns, like a crystal or planets orbiting a star. And Class 3 systems, they're just pure unpredictable chaos, like the molecules of a gas bouncing around a room. But Class 4,
Class 4 is where the magic happens. It's the sweet spot. It's known as the edge of chaos. It's this delicate dance between order and randomness, where stable, complex structures can form, interact with each other, and actually perform computation. This is the zone where we find life, where we find intelligence, snowflakes, galaxies. It's the fertile soil of the gardener's world.
So why does any of this abstract stuff actually matter? Well, because right now, we are trying to create the most complex thing humanity has ever attempted, advanced artificial intelligence. And what we're finding out, the hard way, is that you cannot architect a mind. You have to cultivate it.
And this forces us to completely rethink something as critical as AI safety. The architect's approach is to try and hard-code very specific rules, or align the AI to one single, simple goal. But that's incredibly brittle. It's doomed to fail, because a complex world will always throw a curveball you didn't plan for. The gardener's approach is totally different. It's about creating ethical scaffolding and setting up relational boundaries that guide the AI's own growth toward good outcomes.
And we actually have tools for this already. Instead of hard-coding one goal, we can use something like constitutional AI. This is where an AI is guided by a core set of principles, like a nation's constitution, not just a single rigid rule. We can even borrow ideas from human psychology, like attachment theory, to build a secure, cooperative relationship with an AI. The goal here is what you might call bounded autonomy, giving it the freedom to learn and explore, but always within the safe walls of the garden we've designed for it.
Honestly, the best metaphor I've heard for this is a trellis for a climbing vine. You don't force the vine to grow into a specific shape, right? You build a supportive structure that gently guides its natural, emergent growth in a healthy direction. We're not programming the final outcome. We are programming the conditions for a good outcome to emerge on its own.
So what does this all mean for us? It means our entire relationship with technology, and maybe with the act of creation itself, is going through a massive shift. We have to evolve. We have to go from being master architects, totally convinced we can control every last detail, to becoming wise gardeners who understand that the most powerful, most amazing things in the universe have to be cultivated and nurtured, not just built.
It's a really profound change in perspective, when you think about it. It forces us to accept that some things are just unpredictable, and to embrace the incredible power that comes from that emergence. We have to accept that we're going to get more out than we put in, but that means letting go of the illusion that we're in total control.
The seeds of this new intelligence, well, they're already in the ground. The process of emergence has already begun. So the only real question left is whether we're going to have the wisdom, the patience, and frankly the humility to be the gardeners that this new future requires.